Hello, my name is Kuncheng. This is homework for problem 1, presentation for course probability and stochastic process. Let's do this problem. For this problem, we have a given gx function right there. And this graph is, I draw it and according to the function, like you can see the curve of the gx. And for this problem, the requirement is find and draw fy and capital Fy and Fy in terms of capital Fx and Fx. So according to the gx function, so we can get the range of the y. So the range of the y equal gx, and the range of the y is y greater than, you see, greater than -1 and less than 2. Equal, we have equal. And according to the property of the function, and we can get capital Y equal to 0 if y less than -1 and 1 where y greater than 2. Okay, we can discuss when y in this range. So like we have the three portion is y equal to 2 and y equal to -1 and y from y equal to the -x plus 1 in when x belong to interval 1 to 2. Also, we can discuss according the function, like okay, when y equal to -1, like here y equal to -1, and we have a probability y equal -1 equal, because y equal to -1 where x greater than 2, and we can plug in greater than 2, and we have y minus p x greater than 2, and we can get y minus less, and we can get y minus capital fx2, and we can go through when y equal to 0. So when y equal to 0 in interval 0 to 1, and we can do that is y equal to 0, and the probability y equal to 0 equal to, and plug in the range of the x, and is x greater than 0 and less than 1, and equal f capital Fx1 minus capital Fx0. And we can get this portion when y equal to 2, and in interval x less than 0. So we can get probability y less than y equal to 2 equal to probability x less than 0 and equal to f capital Fx0. Okay, and also we have one more portion, is this one. From 1 to 2, we have the function y equal to gx equal to -x plus 1, and for this one we can use the fundamental theorem, like when x belong to, for the y belong to -1 to 0, and y equal to -x plus 1, we use the fundamental theorem, like fy equal fx divide absolute gx differential, like, and plugging in the because y equal x x equal to y minus 1 minus 1, and plugging in here is fx 1 minus y, and divide -1 absolute, and the function is if x 1 minus y. And in conclusion, we can get a function fy equal to 1 here, 1 minus capital Fx 2, and times we have impulse 1 plus 1, and when y equal to minus 1, and if y equal to fx 1 minus y, when y belong to -1 to 0, like here, we got here, and we have capital Fx1 minus capital Fx0 times impulse y, and y equal to 0, like here, you see here, and we have the Fx0 times impulse y minus 2, where y equal to 2, and we have 0 otherwise. That's the fy. Next, we need to get capital Fy. For capital Fy, we because we have one portion here, this, so we have one portion is capital Fy, sorry, y equal 0, 1, and 0 is y less than -1 and y greater than 2. And we need to know the other two portion is y greater than -1 less than 0, and y greater than 2 greater than 0 and less than 2. We have two more portion. Like, we have the function is in this situation, like capital Fy equal to probability y less than capital Y less than y, and we have, because we see we have the gx, we have the function here minus x plus 1, y equal to minus x plus 1. So plug in, and here is less than y. Okay, and we get x greater than y minus 1 minus y, and equal to 1 minus probability x less than 1 minus y, and transfer the f. Capital F is 1 minus capital X 1 minus y. So this is the function of the situation: y greater than -1 and less than 0. This is the one portion. And for this portion, 0 to 2, and we have the, because 0 to 2, we have the, you see, 0 to 2 equal to 0. So here, according to the function, is a capital Fy equal to probability 1 minus 1 less capital Y less than y, and plug in is 0 less than 1 y 0 less than y, and transfer probability y greater than 0 and equal y minus probability y greater than 0 and less than 0, and transferred to capital F is 1 minus f x 0. So we get the two function in this two portion, and plug in the f capital Fy. In summary, like, we have a function is 0 when y less than -1, and we have the here 1 minus fx 1 minus y when y greater than -1 less than 0, and we have 1 minus capital Fx 0 when y greater than 0 less than 2. We have equal, sorry, and the last one is 1 when y greater than 2, greater equal than 2. So that's it. This is the problem 1.